In lesson 4 or 5, we're going to look at some applications of right triangles, using these terms angles of elevation or angles of depression, and trying to find indirect measurements of the distances or of the angle itself. So for the first one here, to get a good view of a person in front of a teller's window, it is determined that if a surveillance camera on the ceiling at a bank should be directed at a point 5.17 meters to the right and 2.25 meters below the camera. And we've got a little diagram over here. Here's our camera, and we're going out 5.17 to the right and then 2.5 meters below the camera. So we want it to aim it right here. The question is, what is the angle of depression? At what angle of depression should the camera be directed? Okay, so from that information, we want to label some things on our diagram. Okay, so we talked about this 5.17 and 2.25 below. We're going to draw our right triangle. So to complete that, we just draw in the hypotenuse here, that direct line of sight from the camera to that point. And here's our right triangle, and we can label our A, B, and C. Remember, C is always the right angle. And what we're trying to figure out here is the angle of depression. Now, the angle between the horizontal and the line of sight when the object is below the horizontal is the angle of depression. So we're looking at this angle right here, angle CAB. They're labeling that as theta. So that's the angle I want to find. Now that angle has two sides given here to work with, the opposite side and the adjacent side. So we ask ourselves, what trig ratio uses opposite and adjacent? And since we know that the opposite and adjacent use the tangent function, that's the one we're going to use to solve this problem. This is opposite and adjacent. So we're going to set up our equation. The tangent of angle theta, that small angle A, is equal to the opposite side, which is 2.25 meters, over the adjacent side, 5.17 meters. And then, since that's the tangent of an angle is equal to that ratio, to find the angle, we need to take the inverse tangent. Okay, want to make sure our calculator is still in degree mode when we do this because we're looking at angles in a triangle. And when we do that, we end up with 23.52 degrees. So that angle theta has to be 23.52 degrees. Let's consider another problem. Okay, now this one comes out of the MyMathLab. Let me get something to write with here. Okay, so in this one, we're looking at the headlights of an automobile are such that the beam drops 4 inches for each 28 feet in front of the car. What is the angle between the beam and the road? Okay, so here again, we're looking for an angle. So we'll say, suppose this is the front of our little car here, and we've got a headlight somewhere around here. And we'll say here's part of our little wheel going on. So this is, oops, that's the road. Not quite. Hold on a second. Let me change that. Let's make our road a little bit not as crazy. So coming straight out. That's, well, anyway. That's our road. And what we're doing is we're considering this distance here for every 4 inches that it drops. So if I go down 4 inches, we go out 28 feet. Another 4 inches, we go out another 28 feet, and so on. So I'm going to just consider this being our shortest measurement, the 4 inches. Let's do a double mark for that. And the 28 feet, now that's quite a bit of distance out here. Good grief. I'm just making it worse. So let's label that 28 feet. We'll just stop right there. And then to get our angle, see if I can do this a little bit better. Maybe this will work. I'm going to draw this, come out here to that 28 feet mark. And what we're looking for is an angle right here that it makes with the road, that the head beam, because that straight one is the head beam, and this is the road. So we're looking for this angle right here. Now, when I consider this right triangle, let me see if I can straighten this up some now that I remember how to do it. Okay, so with this right triangle, the problem is we have one side measured in inches and this side's measured in feet, and we really need to convert that. So there's 12 inches in a foot, so if I take 28 feet and multiply it by 12 inches, that's the same thing as 336 inches, 28 feet. Okay, so I'm going to use that measurement. Here's my right angle. And so the 4 inches is opposite. The 336 inches is adjacent. So the function we're going to use here is the tangent. Okay, so let's see if I can do this a little better with this. Nope. So we're going to say that's the tangent of theta. Is equal to 4 divided by 336. Those are inches over inches. And then to solve for theta, we're going to need to take the inverse tangent of both sides. So when I do that, I want my calculator in degree mode and take the inverse tangent. And you could reduce this. I'm just going to type it in just like it's written here. The inverse tangent of 4 divided by 336. And when we type that in, our measure for theta ends up being 0.68206, blah, blah, blah. Okay, and that's in degrees. But the question up here asked us to round this off to 1 decimal place. So rounding this off to 1 decimal place, I'm going to look at the 8, and my final answer is 0.7 degrees. I hope this is helpful.